Welcome to Click Academic. This is lesson 2 on the series Mathematical Methods. We will be solving another example on Rolle's theorem. The question says, prove that the function defined by f of x is equal to x to the power of 4 plus 4x squared plus 1 satisfies the hypothesis of Rolle's theorem on the interval, close interval minus 3, 3, and find the number c in the open interval minus 3, 3, which satisfies the conclusion of the theorem. So, solution. We are given the function f of x is equal to x to the power of 4 plus 4x squared plus 1 on the interval minus 3, 3. So, to prove the function, this given function satisfies the hypothesis of Rolle's theorem, we are now taking this interval as a and b. Our a here is negative 3 and b is positive 3. So we should now find the function of a and function of b to see that whether the function is continuous on that point. So f of a and our a is negative 3 is equal to, now we are to substitute minus 3 instead, or anywhere we have x, because we say f of a and our a is negative 3. So anywhere we have x, we should now replace it with negative 3. We have x to the power of 4, so minus 3 to the power of 4 plus 4 into minus 3 squared plus 1. Minus 3 to the power of 4 is 81. Then minus 3 squared. Don't say 4 times minus 3. No, you have to take the squared first. So minus 3 squared is 9. Multiply by 4. 4 times 9 is 36. Then plus 1. So 81 plus 36 plus 1. 81 plus 36 plus 1, which is equal to 118. Then let's find f of b. F of b is equal to f of positive 3, because our b is positive 3, which is equal to, now anywhere we have x in the function, we should now replace it with 3. So x to the power of 4 will be 3 to the power of 4 plus 4 into 3 squared plus 1. This is equal to 3 to the power of 4, 81, plus 3 squared, 9, multiplied by 4, 36, plus 1. So 81 plus 36 plus 1, 118. So f of a is 118 and f of b is 118. The function is continuous because the result is not divided by 0. Then since the function now is continuous, let's see. Remember the condition are two. The first one says the function must be continuous, and the second one, the function must be differentiable. So let's see, can we differentiate the function? We are given f of x is equal to this. So the first derivative of the function is f prime of x is equal to, derivative of x to the power of 4 is 4x cubed. Derivative of plus 4x squared is 8x. Then derivative of 1 is 0. So yes, the function is differentiable because we differentiate the function and we still have a variable in the function. So now we should now say therefore the function is continuous on the, remember, is closed interval, is continuous on the closed interval negative 3, 3, and differentiable on the open interval minus 3, 3. So since the function now is continuous on that interval and is differentiable on that interval, this implies, or there must be a number between this open interval, and we are asked to find that number on that interval, that is on the interval, open interval negative 3, 3, which satisfies the conclusion of the theorem. As we said, to find that number, you have to use the conclusion of the theorem. Then if the function is continuous and differentiable, then remember f prime of c is equal to 0. So we are now to find f prime of c, and then we should now equate it, which is equal to 0. So we don't have f prime of c, but we have f prime of x. So now f prime of c is equal to, anywhere we have x in this function, we should now replace it with c, because here is f prime of x and here is f. Well, now we are looking for f prime of c. So anywhere we have x, we should now replace it with c. We have 4, then x cubed, so it's c cubed plus 8c. This is our f prime of c. And remember they said it's equal to 0. So this implies 4c cubed plus 8c is equal to 0. So to find the value of c now, this is polynomial function. Don't try to take this positive 8 to the other side, because 8c and 0, they are not like term. So what you will do here is to factorize. You should now look for the common factor between these terms, and the common factor is 4c, because 4 is here and 4 can enter or can divide 8, and c is here, c is here, so the common factor is 4c, then open bracket. To get the terms in the bracket, we should divide the previous term by the common factor. So 4c cubed divided by 4c is c squared, then plus 8c divided by 4c plus 2 is equal to 0. Then this multiplied by this is equal to 0. That is, their product is equal to 0. So definitely one of them must be 0. If the product of these two brackets are 0, definitely one of them must be 0. Therefore, either 4c is equal to 0 or c squared plus 2 is equal to 0. So since we are looking for c, we should now divide both sides by 4. c is equal to 0 divided by 4. Or, and here we are looking for c. 2 and 0 are like terms, so we should now collect the like term. C squared is equals to positive 4 crossing equal sign become negative 2. So our c now is equal to 0 divided by 4, 0. Or, since we are looking for c, not c squared, we should now take square to the other side. C is equals, if square across equal sign become square root, so either plus or minus square root of negative 2. So now our c is equal to 0, or c is equal to square root of 2, or c is equal to square root minus square root of negative 2. I mean, here is negative 2. This plus or minus telling you that the values are 2, either positive this or negative of this. So c is equal to positive of this or negative of this. And remember, the interval given is minus 3, 3. That is from minus numbers between minus 3 and 3. And if you look at the values of c here, yes, 0 exists between that interval, but this square root of negative 2 doesn't exist, and square root of minus square root of this negative 2 doesn't exist, because this is imaginary number and this is imaginary number, because we don't have square root of negative 2, so it is not a real number. Therefore, you should now conclude that our c is equal to 0. That is all.